Good day, students, and welcome to Science M.1 with Merivit Education Center. Let's get started with the lesson part. Here are the three things that you will be learning today. Number 1, learn about properties of metals, nonmetals, and metalloids. Number 2, recognize the difference between metals, nonmetals, and metalloids. And number 3, participate in the activity prepared for you about the physical and chemical properties of metals, nonmetals, and metalloids. We have learned that the periodic table can be divided into regions where metals, nonmetals, and metalloids can be found. Now, this is a useful information because the elements in different regions share similar properties. If you look around your house, you will see hundreds of objects made from dozens of kinds of materials. Have you ever wondered why the manufacturer chose the materials they did for each item? Their properties help us to decide which we can use them for. Let's look at some examples. As we all know, most of the elements are metals, and one of its property is, well, they are solids at room temperature with high melting and boiling points. Well, that's except mercury, of course. Here are some examples. Tungsten has high boiling point. Iron has high boiling point and melting point. Can you name a metal element that is not solid at room temperature? Well done! Mercury is the only metal that is not a solid at room temperature. It is a shiny, silvery, liquid metal, sometimes called quicksilver. Can you give another example of elements that has relatively high melting and boiling points? Magnificent! Sodium, magnesium, and aluminum have metallic structures which accounts for their electrical conductivity and relatively high melting and boiling points. Why do you think these electrical wires are made out of copper? What property of copper is useful in this situation? Right. Metals, such as copper, conduct electricity, which is what is needed as an electrical wire. Therefore, metals are excellent conductors of heat and electricity. Do you know what metals can be hammered into sheets as they are malleable? Right. Metals can be pounded into sheets as they are malleable. For example, gold. Did you know that gold is the most malleable metal? Yes, gold is the most malleable metal. In fact, a solid gold sheet can be made into an ornament. Do you know what's on the picture? Exactly. That is a coil of silver wire. Do you have any idea what's the property of silver? Well said. You can pull them into wires as they are ductile. Try to observe the outer part of silver trophy. What can you say about it? Excellent! It has shiny coating or covering and its surface has high reflective qualities. This characteristic of metal is known as luster. Most metals have a high or very high density, but there is a wide range. Density of metals is affected by how closely atoms are packed in the lattice, as well as the density of atoms. Most metals, such as iron on the left, have a high density. Aluminum on the right is a low density metal. Let's summarize the properties of metals. Here we go. The properties of metals are: number one, good conductors of heat and electricity; number two, luster; number three, density; number four, solid at room temperature, that's except mercury; number five, have high melting and boiling point; number six, malleability; and number seven, ductility. Nonmetals can be in gaseous state like helium, hydrogen, nitrogen, oxygen, and fluorine. They are not good conductors of heat and electricity. Some nonmetals can be solid like sulfur, carbon, phosphorus, and iodine. However, bromine is a nonmetal which is in liquid state. What do you know about nonmetals? Do you still remember where you can find them in the periodic table? Exactly. Nonmetals are minority on the periodic table, mostly located on the right hand side, except hydrogen, which is located on the upper left side. When we say nonmetals, they are simply an element that does not display the properties of a metal. Do you think we could make electrical wires out of nonmetals, such as bromine or phosphorus? Why or why not? Wonderful! You could not make electrical wires out of nonmetals, such as bromine or phosphorus, as nonmetals do not conduct electricity except carbon. If metals such as copper are good conductors of heat and electricity, well, nonmetals are not. Sulfur is usually dull and yellow powder. It does not conduct electricity or heat well, and large crystals of sulfur break easily when they are dropped. Sulfur is a nonmetal. Do you know what the pencil is made of? Terrific! Pencil lead is made from graphite, which is it's a form of carbon nonmetal. Why does pencil lead break easily? Right! Pencil lead breaks easily because it is brittle. Most of the solid nonmetals are soft. For example, sulfur and phosphorus, except diamond. Diamond is the only nonmetal carbon. In fact, diamond is the hardest natural substance known. Sulfur has low melting and boiling point, while diamond has high. Let's try to summarize the properties of nonmetals. Number one, they are poor conductors of heat and electricity. Number two, they have a dull surface. Number three, they are brittle and break easily. And number four, they have low melting and boiling point. We have learned about some of the differences between metals and nonmetals. However, there is a third category of elements, which is the metalloid. How is it different from the metals and nonmetals? Here are some examples of metalloids. We have boron, silicon, germanium, arsenic, antimony, tellurium, and polonium. All metalloids. These elements are difficult to classify as either a metal or a nonmetal. Do you know why? Wonderful, because they are not quite metal, but they're also not quite nonmetal either. They just don't fit into either category. Now, does this sound strange to you? Let us explore. These elements have solid metallic appearance, but they are brittle. They tend to be shiny like metals, but brittle like nonmetals. Because they are brittle, they may chip like glass or crumble to a powder if struck. Polonium, antimony, and boron are shiny, brittle, and non ductile. Metalloids conduct electricity at higher temperatures. They usually conduct heat and electricity, though not as well as metals. Amazing, right? Metalloids that conduct electricity at higher temperatures are called semiconductors. Silicon and germanium are good semiconductors. Please answer worksheet number 3 about properties of metal, nonmetal, and metalloid. In the next episode, we will explore some of the uses of the elements in more detail. Happy learning! See you in the next episode.